Zach, if we don't like it, we can throw it away, so don't have to worry about it. So thanks everybody for joining. For this training, I thought I'd ask Zach to come in and give us a discussion about projection systems, datums. For those of us that are doing drone modeling, um, it's something that we have to deal with quite often. And even if you're not doing drone modeling, and you're just looking at just getting survey for a project, understanding how your project fits into the world so that you can geo-reference in other forms of imagery or other data products. It's a critical aspect of everything we do anymore. And a lot of people just think that it's as easy, and to some extent it is just saying, gee, I'm now in state plane, X as opposed to state plane Y. Um, but understanding what your projection is and the datum references are is really important to making sure that you're understanding that your data is good, especially if you're working on a site with a local datum. There can be small shifts, say between NGVD 29 and NAVD 88, and if you're not paying attention and you're not knowing what to look for, those small elevation differences can result in big problems down the road in construction. And so with that, I will turn it over to Zach and let him show us what an expert he is in projection systems. Go ahead, Zach. I
Thank
will
you.
I will give you control if I can figure out how to do that. Why is that not?
I think it says I can share. I think I can share. We'll try it. Or maybe unblock there. Yeah, I guess I need you to share it with me, Russ.
All right, hold on. Normally it comes up and it says 18 participants. What did I? Normally up at the top it just says give control to somebody. Manage recording, stop recording, pause recording.
So alternatively, Zach should be able to request control. I can see that on my screen at the top.
Okay, go ahead and request control, Zach. Oh, give control right there. It's big. Yes. Okay, looks like you've got it, Zach. Zach, are you there?
Yes. Yeah. Can you see my screen?
Yes.
Sorry, I gotta kill the AC here. Um,
You know
the,
what? I'm just going to go through and mute. Doesn't look like it's letting me do that. But everybody, when you're on a call, you should mute your speaker unless you're actively talking.
okay, so yeah, I saw the first thing I saw when Russ had scheduled this is that he left me 2.5 hours, which the good news is I'm not going to use up 2.5 hours. It should go a lot faster than that. But I did have a brief safety minute. Gotta find it here. This is an internal risk. Uh, an internal safety issue. Oh, and I lost it. It's my meme of Greg Gable, the internal scope creep. But it appears that I can't find it. So let's see if I'll try it one more time. There, I've got scope creep back. Actually, like 8 copies of it. So this is something you're going to want to watch out for. Somebody adding stuff onto your project, that can be a real safety concern. You're going to want to watch out for guys like that adding stuff to your project that's not in the original scope order. Now I got to delete 10 copies of my Greg meme. So coordinate systems, what's important, I guess I was going to start there. A lot of times our clients have a preferred coordinate system. For instance, in our MDT survey manual, you would find this line: the preferred coordinate system is state plane coordinates. And it even says NAT 27 coordinates per state statute can't be used. So a lot of times there's going to be some direction given by our clients on what they want us to use. For the state of Montana, they like the convenience of having everything in one database. It causes some headaches during construction for structures, but it's worth it to them to just keep it simple. As I showed on the survey manual there, where it says they prefer state plane coordinates, we followed behind another firm who worked for MDT and did a project that was not on state plane coordinates. This was our Hardin North project. And there were lots of problems with it, and basically the firm that did it got blacklisted for several years. So there can be big business consequences for not paying attention to these small details. There's also something else I would stress, is that this decision can make a big difference in project construction or legal documents related to the project. This screen cap here is on the way to Roundup. It's this is the Bull Mountain Railroad, constructed in 2009. So Dow did the facility staking at the site itself, but this bridge was staked by the firm that was the contractor that was building the railroad, Oftedal. And the surveyor in this case had a poor understanding of state plane coordinates and how they worked. So this bridge was actually, they had precast girders, and they flew up the girders, and the girders were too short due to a survey error of not taking into account the combined scale factor. So the surveyor was fired, and then they had to get another girder custom made. Stuff like that does happen. Typically, it's on a big, heavy structural site. That's where there's a lot of risk of something going wrong with the coordinate system or the scale factor or whatever. And then the other issue is for legal boundaries, you want to be careful. We want to use real distances if we're doing right-of-way acquisition documents or writing a legal description. You don't want to have to explain why the acreage you've reported on your legal description is not the true ground acreage. It doesn't make any sense to people, to the general public. So that's something else we want to watch out for. Some more reasons why we should care is if we've got access to some existing data that costs a lot of money to recreate. Sometimes it's going to be easier to just go along with whatever that coordinate system is. If you consider a LiDAR point cloud, this is very expensive to acquire. The information is very valuable. So if you've got something like LiDAR and you want to make use of that terrain and you want to make it as easy as yourself as possible, then you want to try to use whatever coordinate system control and vertical datum was used for the LiDAR data collect. Let me get back to my list here. Another example would be a monitoring project. So if you've inherited a project where you've got it's on a certain interval of every 5 years or something, something's inspected, there's a good chance you're going to want some relative information to compare from the last time it was inspected or monitored to now. So the right time to have that conversation is at the front of before you do the project. Try to figure out what is there for existing data, and what coordinate system is it on, what vertical datum is it on, and how was the control established. Something else I want to stress is that not all softwares are equal when it comes to handling this stuff. Since surveyors are really at the front end of converting between lat longs and Cartesian northings and eastings, usually survey software is pretty good at it, but and then I would say ArcGIS also handles coordinate systems very well. AutoCAD, Civil 3D, not as much, and then each software is different. And then if we're using a cloud service, you can't automatically trust that the cloud service actually knows what they're talking about. For instance, NAT83 and WGS84 are kind of used interchangeably, and they're really not the same thing. WGS84 is actually hardly ever used by surveyors and in mapping, but you'll see it all over in other software packages. Like those two things are interchangeable, and they're not. It's also really important that we document this stuff, and this is usually kind of a joint effort between the surveyor and the engineer.
Hey, Zach.
Yeah.
If I could ask you a question really quick, NAT83, the differences between NAT83 and WGS84, that's actually something that I've spent time researching before, because you do see WGS84 used so prevalently. Would you explain to people kind of, what the difference is between them?
Yeah, or I'll attempt it. It's not the easiest thing to answer, but there is, if you go to the NGS website, you'll see that this is a document they had to put out because people were wanting to know how they go back in between NAT83 and WGS84. But the short version I'll give you is that WGS84 is, in terms of coordinates, aren't really used by anybody except for the military. So all of the coordinate, NGS data sheets and everything, those are all NAD83. WGS84 uses a slightly different ellipsoid NAD83 than NAD83, which uses GRS80. I think WGS84 uses the WGS84 ellipsoid also. So I think to dive any deeper is probably going to get me beyond what I know. And I guess the important thing is that they're not identical.
And the other important thing to note is that most of your recreational grade GPS units, including our drone imagery, it's all acquired with respect to WGS84.
Yeah, and it's kind of a gray area because they acquire it with WGS84. Really, it's a tough thing to test since there's no WGS84 monuments. I would guess that in most cases like that, where it's a resource grade or it's not, looking for survey grade accuracy of 1 to 2 centimeters, I would guess they're pretty much equivalent. With those things being accurate to 5 or 10 feet, anyways, there's probably not a big difference there. But to be honest, I'm not sure, just because we, as surveyors, we never collect any data in that datum. So, that's kind of interesting to know. When we document the coordinate system, so this needs to be, the surveyor's role is to have some sort of a note that people on the project team should be able to find to see what coordinate system are we using. And that note should describe the units, the control origins, the vertical datum, the map projection parameters, and then ideally, that stuff also makes its way onto plan set documents on a control sheet. This is just leaving a trail of crumbs for the future. You've got Happy Hansel and Gretel, which is like this one. That's what we want, where they left the trail of breadcrumbs for the future. And this looks like a darker one. They probably didn't leave any metadata behind for the people working behind them. For just back to the units here, for large area coordinate systems such as state plane, since those are big coordinates, those can be feet different in terms of if you're taking the same latitude, longitude, and expressing it into those units, they could be feet different. That's one of the more common problems we have if there's some project that went sideways, is somebody's misunderstood the units and is using the wrong units. A lot of states have codified these into their laws when they formalized the NAD 83. I think I've got this list. Jeremy Shupak actually found this for me. This has a list of the units each state uses and whether or not it was required by legislation. You can find that from a simple Google search, but it does matter because if you get switched up on that, we could be talking feet of error. For smaller coordinate systems, the difference between these two is I've got it here. I think it's 2 parts. Yeah, 2 parts per million. So if your coordinates are in the thousands or tens of thousands, you're not going to see the difference between survey feet and international feet. But if they are in the hundreds of thousands or millions, it's going to make a big difference.
I'll try not to keep interrupting you, Zach, but for those of us that are dealing with point clouds, this becomes a super important issue because recap has an error in the program. And even if you explain that you're using, and I get this wrong all the time, I get it backwards, I have to look at the notes, but even if you say that you're using US survey feet, it will do its transformation when it brings the surface into AutoCAD as if it were international feet. And the error can be small enough that at a glance you don't know that it's an error, and it's only after you start looking at feature corners and saying, why is this off by a couple of feet, that you figure this out. So it's not just something that you need to be aware of, it's something you need to be actively monitoring and verifying that as you move from one platform to another, that your transformation is occurring the way it should.
Yeah, good point, Russ. And I don't mind you jumping in at all since you're heavy into this stuff. The first thing I do in most softwares is that's kind of one of the first steps is getting my coordinate system settings dialed in, getting the coordinate system figured out. You want to do that early in any workflow. They don't do it anymore, but I believe in older versions of Civil 3D, if you set that coordinate system and then you imported points from a survey database and then you change your coordinate system, it was actually going to change the value, or it was going to reproject and transform all the points that are in the project and transform all the mapping, which was pretty nuts. So you want to be careful. That's why you want to set that stuff up at the beginning. I don't think that's still an issue with Civil 3D, but it could be one. So in terms of your options, that propeller handout's pretty good about explaining how these are a compromise. We're taking the round world, putting it on a flat map, and there's not a perfect one for every situation. It's just something we kind of have to stumble through. In terms of the sacrifices a map has to make in terms of area, shape, and distance, and direction too. I can't remember what all of them are, but the map projections can't make everything perfect. So your options, the first option would be a custom or poorly planned local system without any metadata. You see these a lot on older surveys, where they assign something a value of 5,000, and then they give it some false elevation of 100 feet or something like that, that's all convenient for doing math with the coordinates and for using smaller numbers, but really we shouldn't be using those any longer. They're difficult or impossible to put into software packages like Civil 3D. Every project is then treated like it's an island to itself. You could potentially have 2 projects right next to each other where you could share data, but you won't be able to because they're on the wrong separate small systems. And then we've also had a project where they had a system like this, and in future phases it expanded farther than they had expected, so we were dealing with negative coordinates, which the software seems to handle okay, but it just looks like a bush league set of plans if we're putting out something with negative coordinates on it. The last option would be like a well-planned local system with published metadata. So you'll hear a lot about low distortion projections, or LDPs. They're becoming more common, and they're pretty portable in terms of you can either directly pick them in software or you can build them in software. Some examples of these state of Oregon has put out their Oregon Coordinate Reference System, where they have all these small little coordinate systems, some of them overlapping. But these were to get away from the problems of state plane is why they came out with these. And you're seeing these more and more in software packages that you could actually dial up the Bend, Redmond, Prineville coordinate system, for instance. I'm not sure if that's in Civil 3D or in ArcGIS. I haven't checked it, but they're becoming more and more common. Another local example, got one other document.
While Zach is looking for that, NECI, which for those of us in Billings, outside of Billings, NECI is a small Indian-owned firm. Oh, that's where you're headed to. I'll shut up, Zach.
Yeah, so you were on the ball there. This is the Rocky Mountain Tribal Coordinate System reference deal, very similar to what was done in Oregon. A lot of similar players were involved in this effort in terms of the National Geodetic Service. Michael Dennis, I think, his name's all over these things. He's kind of a big name in the geodesy world. So these are all well done. But they made these custom coordinate systems for a lot of reservation areas in Montana. And then we've got some that cover other areas like this. There's a Billings projection here and a Bobcat projection. Boo. You can find out how to build these coordinate systems by looking this stuff up, and they're all pretty easy to use. If you look at some plats in the Billings area, you would see Sanderson Stewart, the big plat factory here in Billings. They're putting all their surveys, all their subdivision surveys on this Billings system, so which is kind of a benefit to them and to people who are using the plats after them. So those are two examples, and like I said, those are becoming more and more common. That's kind of the direction everything is heading. And before I guess I get out of there, state of Montana is actually engaged with this firm NECI. The Montana Surveyors Association, I should say rather, is engaged with them to possibly cover the whole state with some small low distortion projections of the areas that haven't been already covered that would end us leave us looking something like the Oregon system.
Hey, Zach, when you get into a place like Oregon, do they tend to use those low distortion projection systems as the standard for, say, as the standard for the survey of projects within those, or do they tend to then default back to a state plane system with the fewer zones?
I'm not sure what common practice is out there. I know Dean and Mike went to Oregon a few years ago and worked for the Bend office, and they were working on the county or the small LDP system that rather than state plane. So I think they're pretty widely used, just because they're a little bit more convenient for survey applications, and you don't have as many problems with construction.
And do you know then, and I'm sorry, I've got a project in Oregon, so I'm kind of side-swiping this conversation a little bit, but are those low distortion systems, at least in Oregon then, do you know if they are available in things like ARC and other, are they in, I forget the name of the database, but the geoprojection database, are they selectable in there to make it easy to bring data in?
I don't know if they have the EPSG code, or if they're in the big database. I just haven't looked, but that is becoming more and more common. I think it was a few years ago, I still remember seeing like Wisconsin county coordinate system settings in ARC. So I would assume, since these were vetted by the NGS, that they're probably in a lot of software packages, but I don't know any specifics there. State plane is the last one here, or the last big one on my list. It's probably the most commonly used. It works great for planning, great for GIS. every software package can handle state plane coordinates, or seems like every software package can handle it. The problems are that since these cover such a large area, especially in Montana, and the elevation changes throughout that area, they're not the best in terms of the bearings being relative to true north. So if you're working with something with a lot of plotting documents, most of those are somewhat closer to true north than not. And so it's more convenient to have the plats closer to north just for search purposes and whatnot, and then building things in terms of your base map. And then distances also are a big problem. Here in Billings, the difference between 100 feet on the ground and 100 feet on the state plane grid is about 700ths of a foot in every 100 feet. So it's not a big deal until you're scaling, if you're scaling in a subdivision that's half a mile long, you're going to have to scale it to make it work for your project. Or if you're building something that requires precise dimensions, something with anchor bolts or a conveyor system, usually you're going to want that distance that you're using in mapping and in designing to be true ground distance, or close enough to it that it is insignificant, that the difference is insignificant. Past the state plane coordinates, some others you might see, UTMs are common for big mapping projects that are maybe multi-state. We hardly ever use them. You might see reference to a modified state plane or a state plane brought to ground. These aren't very portable to a lot of software packages. I prefer not to use them, but sometimes they're required by a client. That's just where they take a state plane mapping project and scale it at one location to make the distances match true ground distances, but then everything away from that point at which they scaled it is no longer on the state plane grid. It's an easy way to get people confused as to what's state plane and what's not, so I tend to try to avoid it if I can. And then you've got geographic systems like lat longs, and interestingly, GPS actually all runs on Earth-centered, Earth-fixed, which is a coordinate system that runs on XYZ, and then they take that and spin it into lat longs. In terms of what you should use for your project, you always want to use what the client wants, and if you can document that in the scope of work, that's great. If they're building an industrial facility where there's going to be a bunch of building grid lines and concrete and structural steel involved, and they say they want it on the state plane, I think you owe it to them to tell them that's not a good idea and why. If the client doesn't have a preference, I like to use things that are published, like state plane, on non-construction projects, and then LDPs on construction projects or projects that require legal descriptions. And a lot of times we don't get much of a decision in those cases. We built these are the facilities at Bull Mountain Mine. I lost it. Anyways, it's a complex system of conveyors and structures. That project was all done, and it was designed in state plane. It was designed on the ground, and then they sent it to the structural designer sent it to us. Then we had to scale it into our civil stuff, and then we had to be aware of the state plane problems or challenges, I guess, as we're staking things out. So it can be done. Even with structural stuff, but it is not ideal.
Zach, do you have the ability to create a low distortion system? Is that something in your wheelhouse?
Yep, that's right in my wheelhouse. If there's one already made for an area that somebody's published and got out there on the web, for instance, if I was doing a project in Billings and we wanted to try to use an LDP, I would try to use the Billings projection that NECI put out, or if I'm in Oregon, I try to use one that's already there. But in spots where there aren't any, that's something I can do. It's probably something that's going to take me about a half hour to an hour. It's not very complicated. It just involves figuring out about the approximate elevation of the mapping area, the area you want to cover, and where basically how much you want to cover in terms of the coordinates, because you don't want to run out of room with your coordinates.
And then you would create a PRJ file that could be imported into other types of geographic software for porting in data, correct?
Exactly. And my chosen place to do that would be in Global Mapper. So this is the Global Mapper projection configuration display. If I wanted to make my own projection, I could do that here by filling in this information. And you can also do this. So if we were doing that and we're making a new PRJ file, probably you also want to, most projects we're using Civil 3D, you want to set up a drawing in Civil 3D with the coordinate system in it as well, so they can access things like GIS property lines, any sort of GIS data, and use it in the Civil 3D drawing. We want to set it up there, obviously, in all the survey files. Basically, if we can set it up anywhere in any software, then you want to take advantage of it being geographically accurate. But yeah, we can set up LDPs on a project basis also.
And this is beyond the scope of this discussion, but you'll note that there was a transverse Mercator at the top of that dialog box. When you get into cartography, there are a number of different mathematical models like Lambert conformal and just Lamberts and all kinds of different things. We typically use the transverse Mercator. That's typically what you use, correct, Zach?
Yeah, if I'm making if I'm making my own, that's usually what I use because it's really easy. It's good for covering kind of a rectangular or square area, and you don't have to spend a lot of time on it. If you're more geodetically inclined, or working on your master's degree in geodesy, you might want to try something else like a Lambert conformal conic projection, or some of the more fancy ones where they probably do make a better job of evening things out. But for a simple in-house LDP, I use transverse Mercator for almost everything. The vertical datum is a little bit less complicated. Again, you're going to use what the client wants. It's almost always NAVD88, especially if it's, we're worried about floodplain mapping or any sort of hydrology. It's almost always going to be NAVD88. And then you'll see in survey stuff, you'll see reference to a geoid model. And in Russ's handout from Propeller, they do a good job explaining what the geoid model is. But it basically goes from taking your GPS coordinate on a round ball and then getting a real world elevation from it. You might sometimes see NGVD29 from older projects, or an assumed vertical datum. For a long time, the city of Billings kept a vertical datum with some arbitrary elevations kept on certain fire hydrant bolts. And fortunately, we've gotten away from that, but unfortunately, you will probably run into it too, where cities wanting to use something that's kind of short-sighted in terms of the future.
I'm going to interrupt again real quick, Zach. So for us in DI, the NGVD 29 versus NAVD 88 is a big deal, especially with the age of the infrastructure of the projects that we're typically working on. It is very common to see things in NGVD 29, and the difference between NGVD 29 and NAVD 88 is not a constant. It varies with location. Looks like Zach's going to VertCon. And so there are applications that you can use to determine what that difference is. Not to belabor the issue, but just know you have to be very aware of what the datum of the data that you're using is with respect to, so that as you go forward, you can be working in the same units. And again, if information is given with respect to NGVD 29 and you think it's NAVD 88, it can have serious complications or implications on the design and the layout of whatever it is that you're working on.
Yep, yeah, that's a good point. So VertCon is, you can just Google VertCon NGS and it would bring you here. And this is a tool, haven't used it real recently, but at some place we can punch in a coordinate and it must be so you must have to go to the coordinate conversion transformation tool to do this. But you can punch in a latitude, longitude. There might be options for state plane coordinate, metric state plane coordinates also, but you punch that in and then you tell it, tells it the XY, and then it's going to give you an estimate of the difference between NGVD29 and NAVD88. But this is not an exact science. I mean, it's an exact science, but what's on the ground, you might have differences inconsistent with the differences you're seeing in VertCon. So if you're working on a project with NGVD29 datum, if at all possible, you want to get yourself on some real world monument that can tell you with a published value with the NGVD29 value, and then you can make a comparison between that and NAVD88, which will help people going forward. So you can use VertCon. It's kind of a method of last resort if you can't find any monuments, previous monuments. But ideally, if you've got a project on an older datum, if any way possible, you want to try to find some sort of monumentation to do your check there. Since at the time those things were built or whatever, I'm sure they weren't caring that much about the global accuracy of their vertical datum. So, as I said, one of the keys in my mind is that we should be documenting coordinate systems and control origins in our projects really well. In the survey folder, hopefully there's a note, a text file note that looks something like this. This is a note out of a recent LDP that we built. So if we're reading through here, all of this fancy jargon, we've got the North American datum of 1983. You can think of this as being the lat longs of your project. The geoid model used to interpolate the orthometric heights. This is the map projection. This is the information you would punch in to something like Global Mapper. Basically, you need to provide everything that's in here that you would have to punch in there. And then hopefully that's also documented somewhere on the plan set. The key note here in this coordinate system note is at the very end here, for the purposes of this project, grid and ground distances are equal. If you compare this to a project where we use state plane, we've got a different note here. Where it's the mapping grid distances do not equal true ground distances. So in that case, we've got to use what's called a combined scale factor to go from a grid distance, which is what's mapped or what's in AutoCAD, to a ground distance, which is what the real world is. And then if we're looking at like the conversion cycle, that's telling you how much this differs from true north, and you'll see state plane 37 minutes versus a low distortion projection, which was at 6 minutes. I'm not sure where these two were at, but that's telling you how much it differs from true north, which is probably not a big concern unless you're doing property surveys. In terms of what's coming in the future, Russ mentioned in his meeting invite that NOAA is replacing NAD83 and NAVD88. And one more, I want to back up briefly here. So state plane, you'll see also is NAD83 2011 for the datum. So these things have the same datums, but they're completely different coordinate systems. Oftentimes, you'll get a request from a client, or you'll say, what do you want for a coordinate system? And they'll say, give me NAD83. and usually they mean state plane, but that's not really the same thing. These are the latitude, longitude used to project the coordinates into state plane. So I guess it's just something to be aware of, that this does not mean state plane, but some people will use it that way.
Hey, Zach, here's a question that I've often been confused with. If you go into something like Global Mapper and you're picking that horizontal datum, you'll often see NAD83 and then, the various iterations. Is 2011 the current one?
Yeah.
Yeah.
So 2011 is the current one, and that was
Okay.
That's one of my last points here. Is there's really not a lot of difference. Let's see if we can find some different datums here. Okay, so yeah, this is nuts. Look at what they've done here. All I ever use is this one. For documentation purposes, there might be some value in noting that we're actually in the 2011. But what we're really trying to do is go from lat longs to northings, eastings, and these all give you the same thing. So if you saw a NAD83 1992 or a NAD83 1996, in terms of that conversion between the lat longs and the grid coordinates, it's going to be the same. So we always use NAD83 even if we're in NAD83 2011. But there may be some utility in documenting that as being actually NAD83 2011. But if you're asking me today, I'd still use this for almost every project where I got NAD83. And same goes for Civil 3D and even ArcGIS. But others may have different opinions there. As I said, LDPs are gaining in popularity, and then we already talked about how Montana is considering covering the state with these using the firm Russ discussed earlier. Yeah, and then the other note was the one we just covered there. So anybody else has any questions, I'd be happy to take them, but that's all I was planning to cover, at least that's all I prepared, but I am happy to entertain any questions. Okay, well, Russ, you got any closing notes here?
No, just thanks for taking the time to put this together for us, Zach. Sure appreciate it.
You bet, yeah. And if anybody has any project-specific things that they run into, I'm a resource that's available to help you. So hit me up. Thanks, everybody.
All right, thanks everybody.
Thank you, Zach.
Thank you.